Okay, so we're going to talk about the second way to solve systems of equations through elimination, or part 2. It's a very important concept, number 1. In some systems, there are not similar coefficients. So in these cases, you're going to need to multiply one or both equations by some number so that you can eliminate one of the variables. This is a little harder than the first type of elimination. So let's look at how this might work. Okay, so we're going to solve this system. We have 2x plus y equals 5. 3x minus 2y equals 4. Notice none of these variables have a coefficient that will cancel out. So we can't use addition or subtraction, we've got to multiply. So if we line these up, which one's going to be the easiest? Well, if you notice, here you do have a plus and minus, so if we can fix it so that their coefficients are the same, they will cancel. So we're going to leave this one, but let's multiply it so that we have a 2 here with this y. So we're going to multiply by 2. And really, we want to multiply everything by 2. I drew my parentheses in the wrong place. So this is going to stay the same all the way across. This is going to become, when I distribute my 2 all the way, 4x plus 2y equals 10. Recap, what did I do? I distributed my 2 to every term inside of these brackets, so that my new equation is 2x plus 4y, or 4x plus 2y equals 10. Now I can add them because my two coefficients that go with the y are inverses. Now, 4x plus 3x is 7x. Positive 2y and negative 2y give you 0, so they cancel out like we want. And then 10 and 4 give you 14. Now we have 7x equals 14. We can divide both sides by 7, so we get an x value of 2. Now, of course, we need an ordered pair, an x and a y, so you've got to take the x value and plug it back in to get y. Either equation, but you've got to remember to go back to the original, not this one we souped up, although it would probably work. So if I take this 2 and plug it in here, 2 times 2 is 4, plus y equals 5. When I subtract our 4 from each side, I find out that my y is going to equal 1. So my solution is that these two equations would touch at 2, 1. Okay, so recap what I did. I multiplied my entire equation by 2 to make it so that I had coefficients that would cancel out. Let's look at another one. Alright, so we have 7x plus 3y equals negative 1. 4x plus y equals 3. So when I line them up, once again, nothing cancels. But look, I have a plain y here, a 3y here, so I can multiply everything here by 3 to make it work. So I'm going to multiply this whole thing by 3. I'm going to leave this one alone and multiply by 3 so that now I have 12x plus 3y equals 9. Now, these are both positive 3y, which means I have to subtract. So I'm going to come over here, because I ran out of space. 7x plus 3y equals negative 1 minus 12x plus 3y equals 9. What happens when I do that minus? It hits every sign. So every sign changes. So what I really have is minus 12x minus 3y equals negative 9. So now my 3's will cancel. So I have 7x minus 12x equals negative 5x plus 0 equals negative 10. Negative 5x divided by negative 5 is, of course, going to cancel. Negative 10 divided by negative 5 gives me x equals 2. Take your 2, plug it in for an x because you need a y. 7 times 2 is 14 plus 3y equals negative 1. Subtract 14 from both sides, you find 3y equal to negative 15. Divide by 3, you find y equal to negative 5. So my solution is that these two graphs or lines would meet at 2, negative 5. Now what happens when you don't have a plain old y or a plain old x there? What happens when you really get a tough system? Like this one. There's a coefficient beside every single variable. So I'm looking at 2x minus 3y equals 2 and 5x plus 4y equals 28. Nothing's lining up nicely. In this case, I have to multiply both. So it's almost like a fraction where you're looking for a common denominator and you have to multiply everything involved with that fraction. So this time I'm going to multiply everything here by 4. And what I'm choosing to do is make these y's be the same because I have a negative here and a positive here, which means they'll be easy to cancel out. So what I'm looking to do is make this become 12. So that's why I chose the 4. Here I'm choosing a 3 because 3 times 4 will give me 12. So when I multiply everything here by 4, I get 8x minus 12y equals 8. When I multiply all this by 3, I get 15x plus 12y equals 84. Now there it is, my inverses, and that's what I need in order to cancel out. So 8 plus 15 is 23, negative 12 and positive 12 is 0, and that's what I want. 8 and 84 is 92. Now I have 23x equals 92. Divide both sides by 23, I get 4. So I know the x value in my solution will be 4. To find the y value, plug it back in to the original equation. So 2 times 4 is 8, minus 3y equals 2. Subtract an 8 from each side. I get negative 3 divided by negative 3 equals negative 6 divided by negative 3. Y is going to equal 2. So my solution is going to be 4, 2, meaning that these two equations would cross at over 4 up 2. So now you know 3 ways to solve systems of equation, 2 different types of elimination, one a little harder than the other.